Hi students, this is T. Balakrishna, Chemistry Lecturer, GPT KOTHAGUDEM. Our topic is Bohr's atomic theory limitations. Limitations of Bohr's atomic theory. The first points in limitations of Bohr's atomic theory. Bohr's atomic theory failed to explain the spectrum of multi-electron atoms or ions. So multi-electrons means which atom or ion have two or more than two electrons. We already learned in previous part. So here helium atomic number is 2. It is printing mistake. It is 2. It means it has two electrons and two protons. So two electrons. So this theory failed to successfully explain the spectrum of one electron atoms. Failed to explain the multi-electrons means two or more than two electron atoms. So this theory failed to explain the spectrum of helium atom. And next example, lithium atom and lithium ion. So atomic number is 3. It has 3 electrons. This theory successfully explains the spectrum of lithium plus 2 ion, but failed to explain the lithium and lithium plus ion because lithium have 3 electrons, lithium plus have 2 electrons. They have 2 or more than 2 electrons. So this theory is failed to explain the spectrum of multi-electron atoms. Next point, this theory failed to explain the fine spectrum of hydrogen. Here, a fine spectrum of hydrogen means a spectrum recorded by using of high resolving power spectroscopy is called fine spectrum. It is contain many closely spaced lines. According to the Bohr's theory, hydrogen have only one electron. So according to the Bohr's theory, it gives only one line, but it thus that one line is not contain only one line. They have multiple lines. So here you observe that it look like one line, but it is not a one line. It is have many number of lines. So Bohr says that it has only one line, but uh, further scientists explain that it's not a one line, it has a multiple lines. They found that that phenomena by using of high resolution spectroscopy. So it is not a single line, it has a multiple lines. So Bohr failed to explain this multiple lines. Next, third point, this theory failed to explain the Zeeman effect and Stark effect. Here, Zeeman effect means the splitting of spectral line in the applied magnetic field is called Zeeman effect. Here, Stark effect means splitting of spectral line in the applied electrical field is called Stark effect. When you saw the diagram, so here is the one line is splitting into multiple lines. Where when it is split into multiple lines, when you are up, when it is enter into the magnetic field, so one line is split into multiple lines. Such type of splitting is called Zeeman effect. So one line is split into multiple lines in applied electrical field is called Stark effect. So Bose did not explain the splitting of spectral lines. So here no chance to explain the Zeeman effect and Stark effect. When we discuss the splitting of lines, so we further discuss about the Zeeman effect and Stark effect. Bose not introduce the splitting concept, so there is no chance to explain the Zeeman effect and Stark effect. Here Zeeman effect and Stark effect means splitting of spectral line in applied magnetic field is called Zeeman effect. Splitting of spectral lines in the applied electric field is called Stark effect. Bohr failed to explain these two splittings, Zeeman effect and Stark effect. Next one, Bohr proposed the flat model of atom, but it is found that it has a three-dimensional existence. According to the Bohr's theory, atom has two-dimensional structure, flat model, but experimentally proved that Bohr atom have three-dimensional structure. So when you saw the diagram, according to the Bohr's theory, is in a two-dimensional structure. It have only x-axis and y-axis. That is called two dimensions. So experimentally proved that atom not have a two-dimensional structure. It has a three-dimensional structure. One is the x-axis, another one is a y-axis, another is z-axis. Three dimensions are there. One is a height. So one is a height, length and width, and depth or height. That is called three-dimensional structure. Is a length and width only. That is a two-dimensional structure. Again, the Bohr's theory, atom has a two-dimensional structure, but experimentally proved that atom has a three-dimensional structure. It is existing in three-dimensional manner. Bohr assumes definite orbit for a revolving electron. It is against the wave nature of the electrons. Here, Bohr introduced that atom uh, revolves in a fixed orbit. So fixed orbit. So it is a the here electron have a particle nature and wave nature. Here Bohr only concentration on particle nature. He uh, not concentration on wave nature. It is a this theory is against the wave nature. According to the Bohr's theory, electrons revolving in the circular path like this dotted lines, but experimentally proved that electrons not revolving in the circular path. They're revolving in circular manner, but not in circular path. They're revolving like these waves. Are you able to follow me? So here, electrons, it is a nucleus. The distance between the nucleus and orbit is called radius. Okay, right? So here, electrons are revolving around the nucleus in circular orbit. So here, both assume that there is a definite orbit revolving in fixed definite orbit, but they are not revolving in fixed orbit. They are rotating like waves. So this is called waves. Okay, so it is in a nucleus, it is in an orbit, but electrons in not in rotating in a particle nature. They have particle nature and they also have wave nature, but here Bohr concentrated on only particle nature. He forgot to he not concentration on wave nature, but electrons have wave nature. So his theory failed to explain the wave nature of the electron. Is it clear? Right. Next one. As for Bohr's theory, the position and velocity of the electron can be determined accurately and simultaneously. This is contradiction with the uncertainty principle proposed by Heisenberg. We know the Heisenberg uncertainty principle. We can't say the position and velocity of the electron accurately and simultaneously. But according to the Bohr theory, we can say the position of electron and velocity and position of the electron easily, but experimentally it not possible. So here Heisenberg introduced that principle. I try to explain that principle. So you saw this representation. When the electron revolving around the nucleus in fixed circular path, Bohr says that we can say the position of the electron and velocity, speed of the electron exactly. But it is not possible. For example, I want to say the position of here electron is there, so it's not in that particular position, so it is rotating. So if you say the position of the electron is presented there, it not have velocity. For example, it is a position. I say the position, electron is present in there, so I think you it is not a velocity, it not moving. It's not moving. If you say the position, you can't say the moving. So if you say the moving, you can't say the position. Is it clear? So if it is rotating, you can't say the position. If you say the position, you did not say the velocity. So it is called we can't say the position and velocity of the electron. Here we say the position, but we can't say the velocity. But here we say the velocity, but we can't say the position. So we can't say the position and velocity of the electron simultaneously and accurately. And at a time, we can't say the both the values exactly. When you say the both the values exactly at the same time, there are a slight difference between the slight difference from the original value. Is it clear? Very, very important point. So right, very, very important points. This theory failed to explain the spectrum of multi-electron atoms. This theory failed to explain the multi-electron atoms and Heisenberg uncertainty principle, three-dimensional model. Thank you, students. This is T. Balakrishna, GPT Kothagudem, chemistry lecturer.